let's complete the state of stress due to Fy 160 pi before we move on to the next load. So as I said earlier, A nothing, and then B we have tau 53.3 and negative in the positive x, so it will be 53.3. okay, SI, of course on the y plane we just flip direction, so that is the 2D stress block due to Fy. And now move on to the load due to Mx. Load due to Mx. And Mx, as you can see here, is about x longitudinal axis. It will create a torsion. Mx basically a torsion. So keep that in mind. And torsion will create the shear stress on the cross section. So let's do here stress due to Mx. And Mx we already find out it equal to 1280 per inch. 1280 per inch. So from that, let me draw again similar to the cross section here in 3D, in 2D, so that we can be able to easy to imagine what is that about. So we also have on AB, we have that E, Z, this is Y, and we have that point here, this is point B, and we have point here, which is point A, and the X is perpendicular to the incline, and the torsion Mx is negative. Mx is negative, and that is a torsion, as you can see. So that right down here, it's actually that is a torsion. Okay, so that torsion, and it go from rotate from A to B, as you can see there. So that torsion here T. Let's move down outside here, the torsion T, and that equal to Mx 1280 per inch. So when it torsion, it will create the shear, right? So shear, as you can see let's draw it down here. At A, the shear with that torsion, it will go that way. And that way, as you can see, it direct to Z and on the X plane. So that is, as you can see, that is tau XZ. And at B, with that torsion, it have to go horizontal. And that horizontal, that it will be tau in Y direction, or still on X plane, XY. So you see that there, okay? So with that, we can be able to find out, okay, at A, we determine that it's tau XZ, tau XZ. And with that torsion, it will be create a positive XZ on the Z axis. So it will be equation T rho over J and 1280 pipe, 80 pipe, 1280 pipe. Have pi in here, per inch. So from there we can move down here, 180 pipe. Rho is the radius of the shear, so it will be of the shaft, so it will be 2 inch divided by the J, so pi over 2 radius power 4, and from that we have 320 psi, that is tau x, tau xz. And then we have B. On point B, we have tau now, as I showed you, tau xy on x-plane, direct to y-axis. So it will be the same number, tau t rho over j. And with the same number we have, it also equal to 320 psi. And in this case, as you can see, it will be negative, because that opposite to the y direction in there, so it's negative. So we can draw the stress block for just load due to the torsion. So we have A, we have B, and x-axis, z-axis, and we have x-axis, y-axis. So tau xz and positive 320 on the positive x-plane. So you will have that going up here, going down, and of course that just change the direction. So that is tau xz 320 psi, and tau xy for B equal to negative 320. So on the positive x-axis, it will be opposite of y. My y positive going down, so it here, then that one going down. Oops. And this one is, you see, tau xy equal to 320 psi. So that is stress due to mx, and then you can continue to stress due to my. And my equal to 2560 pi per inch. 2560 pi per inch. Then we can go ahead to draw the cross section to be easy to visualize. And in this case, still z, and just y, and x again perpendicular to the surface. And my, as you can see there, that go negative to the y-axis, and with that my 2565, and I can put it down here. It actually from the top to the bottom, outside of the cut that you have that, and that is my. And the point here is point B, and that here is point A again. And with that moment, and that is actually a bending moment, and that bending moment, it will create a maximum at the outermost fiber and minimum at the neutral axis. So as you can see, for this case, with that moment that the neutral axis is here, then there is no normal stress at A, but the maximum at B. With that, because A go through the neutral axis of that moment about y-axis. So with that, we can have point A, sigma x equal to 0, because go through the neutral axis. B, sigma x equal to, because that bending moment creates the normal stress, so it will be my over I, and with that it will create a positive, and you can see the bending that way, positive at B, positive on cross section at B. So we have that is 2565 B at outermost fiber, so y equal to C, which is the radius, so 2 inch divided by I, 5 over 4 2 power 4. And with that, it equal to 1280 psi. And we can be able to again do the state of stress for this block, and that is point A and point B, and we have X and we have Z, and we also have the X and Y. Sigma X equals 0, so nothing at A. B have sigma X is the positive, is tension at B. So we have that one here is 1280 psi. Opposite also 1280 psi. So the last one is the stress due to mz. Stress. And that mz equal to 10,245 pound-inch, and that also a positive about z, right? Right hand rule, positive moment, and that create a bending moment as well. So mz here 10,245 pound-inch. So let's draw that cross section. Then you have here Z, and you have Y. That's point A. This is point B. And for the bending, it's positive. So in cross section, the moment mz, it will go from left to right, so that is mz. And as you can see that the neutral axis for the mz, it become the z axis, NA. So what does that mean? The normal stress due to mz at B equals 0, and at A is the maximum. So from that one, we can see that at A we have sigma, and in this case still sigma x equal to mz y. Just put my over I, and that actually mz. So let's put that one in tension so we are not confused. Tension. Negative. Tension. Good. And this one, it will be tension. And the next one also tension at A, so we plug in 10,245 y equal to 2 inch over I, 5 over 4 to 4, and that number equal to 5,125 psi, and that also in tension. And of course we have B, we have sigma equal to 0 because go through the neutral axis. So from that we draw the stress block for these scenarios A, B, and as you can see it's a lengthy process that we can have here. So X, Z, and that one is X, Y, and here we have the tension, so we have that one in X 5,125 psi, and at B nothing.